Good morning. Today we're working on our very first lecture of the class. Sorry, I'm going to be shifting that around. Okay, terminology. First off, before we can get started, we have to be speaking the same language. So it's important for you to understand the terminology or vocabulary of a math class, of an algebra class. All right, so first, variables. Variables are the letters used to represent numbers. Usually we have like X or Y, sometimes the A, B, C's, that kind of thing. An algebraic expression is a combination of letters and numbers using the operation of addition. So this is going to be things like 4x minus 2. All right, that's an algebraic expression. Now, we also have equations, so I'm going to show you the difference between an expression and an equation. So an expression would be, for example, what I just wrote, 4x minus 2. Now, an equation would be 4x minus 2 equals 10. An expression might be 3a plus 4. An equation would be 3a plus 4 equals 13. There we go. Okay. Expression, equations. As you can see the difference, what do you see it as? Yeah, it's the equal sign. So it's these equal signs. All right, substitution, replacing a letter with a number. So if I used our first expression up there, 4x minus 2, and I told you that x is equal to 3, you'd get 4x, whoops, not 4x, come on, there we go. I was supposed to get my eraser. There we are. Okay, 4x was 3, so I put a 3 in place of it, minus 2. Now, evaluating an expression would be to do the substitution and then come up with a solid number. So if I use that, 4 times 3 is 12, minus 2 is equal to 10. All right, now, order of operations. You perform grouping symbols first, okay? Then we evaluate. So that's a G. Then you evaluate all exponents, E. Okay, and I've got to shift my little video here. I'm not sure how to move that. I'm supposed to, okay, I'm going to just turn it off for a second. All right, so do all multiplication and division as they occur left to right, like you're reading a book. And then addition, subtraction, same rule, left to right, as if you were reading a book. So notice your addition and subtraction are the very last things you do. Unless, of course, they're inside of a grouping. Okay, so I'll turn the video back on. Hi, I'm back. Okay, now evaluate the expression given when x is equal to 14. Okay. So what we do is we take the 2x and change the x for the 14. And we're going to add 13.25. My writing is atrocious because I have to have this sitting up a lot so that the video, you're not looking up at my chin. Trust me, this is better. All right, so 2 times 14 is 28. We still have to add the 13.25. And now we've got 28, 38, plus 3 would be 41.25. All right. Evaluate the expression 8y plus 1 plus 10x, given x is 3 and y is 8. All right, so 8 times y is 8, plus 1 plus 10 times x, which is 3. Okay, we don't have any groupings except for individual numbers, and that's okay. So next we do our exponents, no exponents. Now multiplication and divisions. So we do our multiplication of 8 times 8. We do it like we're reading, so left to right. 8 times 8 is 64. Then we have plus 1, and then we have plus 10 times 3 is 30. Now we've done all our multiplications, and now we do our additions. So we've got 64 plus 1 is 65, plus 30 is 95. So our final answer is 95. Okay, now to evaluate 6x minus 15 over 3x when x is 5. All right, so we have 6 times 5 minus 15 over 3 times 5. Okay, we did our substitution. Now, GMDOS, we do have some groupings here. Our numerator and our denominator are grouped, so we have to simplify those first. Okay, so for my numerator, I'm going to get 30 minus 15. Okay, 30 does not start with a 1. 30 minus 15. 3 times 5 is 15. Absolutely, I am not ready to cross anything off, so I can't do that yet. I know a lot of you are looking at those two 15s and thinking, ooh, I can cross those off and the answer is 30. No, we cannot cross them off. We must do our grouping first, so we have to do the top first. So 30 minus 15 is 15. It's divided by 15. Well, any number over itself is 1. See, it is not 30, it's 1. Okay. Now, I want you to do the next two. All I'm going to do is give you an answer. Well, yeah. Okay. So if x is 5, what do I have? For number 1. Come on, you can do it. 5 minus 3 is? Yeah, 2. 4 times 2 is? 8. So we have 4 times 2 is 8. So that's your answer. All right, now you got to plug in two things. Try number 2 here on your own. So my answer, 2. Hopefully that's what you got. All right, so how I did that was 2 times 3 plus 3 times 6 over 2 times 6. 2 times 3 is 6. 3 times 6 is 18. 2 times 6 is 12. 6 plus, can't cross anything off. 6 plus 18 is 24. Over 12, well, since 12 goes into 24 twice, it's 2. All right, let's move along. All right, translating to algebraic expressions, changing words or phrases into an expression. I have keywords we look for. Plus, some, more than, and increased by are for addition. Subtraction has minus, difference, less than, and decreased by are your common terms for subtraction. Multiplication, you have times, product, twice, of. Now remember, twice a number just means times 2. All right, quote, division. divide, quotient, ratio, per, and just like twice, sometimes you have half, which again means divided by 2. All right, let's see what this says. The sum of a number and 2. Well, we don't know what the number is, so we place an x or an a or some variable for it. So I'm going to use x just because that is traditional. So the sum, so that's a plus, of a number and 2. There we go. The difference of a number and 2. So x minus 2. Twice a number, 2x, increased by plus 3. The quotient, remember quotient means divide, the quotient of 14 and a number. All right, I want you to do these last 3. The sum of 7 and a number, so 7, sum, so it's a plus, and then our variable, x. You could put a, you could put whatever you want. The sum of 7 and a number, let's see, let's just for fun say m. You can use any letter you want to. The difference of 6 and a number, come on, you can do that. Difference means, that's right, subtraction. All right, so the difference of 6 and a number, we're going to use b. The quotient, again, quotient is divide, of a number, so we used our variable, x, divide, and 6. So 6, decrease, that's subtraction, by 4. There we go. All right, now this is not x minus 4 all over 6. This is x over 6 and then minus 4. You have to remember the order. All right, let's move on. Subtract from and less than. Careful here, as you will have to translate these backwards. All right, it's not going to be this subtracted from 6. So think about what that's saying. That's actually saying you take 6 and you subtract from that number a variable. Okay, so it's 6 minus x. So you have to be careful of subtracted from. Less than is the same way. 8 less than a number is going to be the number minus 8. This matters because order matters in subtraction. That's how we get our negative numbers, right? Order matters. 6 subtracted from a number, so that's going to be x minus 6. All right, and I want you to do the 9 less than a number. You can do that. All right, equations. It is a statement that 2 algebraic expressions are equal. An equation will always contain an equal sign. So these are 2 equations. Okay. All right, solutions. Values that make the equation true. Determining if numbers are solutions to equations, we plug them in. Determine if 3 is a solution to the equation. Okay, we're going to use the previous equations. Okay, on my slide I can't go back to them, so we're not. I'm going to come up with an equation. So we have 2 times x minus 4 equals hey, stop it. Four times x minus plus 2. So we're going to go 4. All right, does 3 work? Well, we got to plug 3 in to find out. So I have 2 times 3 minus 4, does that equal 4 times 3 plus 2? Well, 3 minus 4 is negative 1. So I have 2 times negative 1 equals 4 times 3 plus 2 is 5. Well, I'm pretty sure that doesn't. I've got a negative 2 equal to 20. Yeah, that doesn't work. All right, so here I want you to do these. I want you to substitute in the 20 and give it a try. I'll give you a little bit of time. Yeah, I know. I should sing to you or something. Do, 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 do. Yeah, that's silly. Okay, so now we've got an answer, hopefully. And yes, 20 is an solution. So what you did was you substituted in the 20 for the x, and then you evaluated the 20 minus 8 and got 12. And that is not supposed to be 20. That is 12. There we go. So yes, 12 does indeed equal 12. Now we're going to the second one and plug in the 7. I know, here we go. You're doing the work. Okay, so now we plug in our 7. 7 minus 5. We evaluate the parentheses. So 5 is 2. We do our multiplication. And sure enough, 6 is equal to 6. So the answer to this one is yes. All right, translating English sentences into algebraic equations. Use the keywords that we did talk about before and the following keywords for equal. Is, was, yields, gives, is the same. Okay, the product of a number and 7 is, I'm highlighting that because I want you to remember that's our equal. All right, so the product of a number, product is multiplication. So 7x, product of a number and x, number and 7, is 21. All right, 6 less than 3 times a number is, all right, but now we had, let's see, less than, oh, sorry, I apologize. That said is the same as. That's all the equal sign. All right, the number increased by. All right, so let's translate this now. Less than 3 times, so what we have to do, remember this is where we have to flip it. So 3 times the number minus 6 is the same as the number increased by 12. You can just translate it straight over. It's actually really easy. All right, so now I want you to do number 1 here. Okay, first we're going to identify is equal to, so that's our equal sign. The first half, the difference of twice a number. All right, so that's 2x, and then we're going to subtract 3. So twice a number. Whoa, I'm still on highlighter, aren't I? Let's get rid of that guy. 3, the difference of twice a number minus 3 is equal to, and then we just have the single 27. There we go. That's not too bad. Did I accidentally hit that twice? I don't think so. Okay, formulas and models are handled in a way similar to what we do when evaluating expressions. Values given are substituted into the equation, then the order of operations is used. Oh, I don't have that here, do I? All right, apologies. Somehow my slide did not end up with the equation. Your papers should. F equals 9 over 5 C plus 32. Okay, when we look at this formula, it's actually pretty easy. We know the freezing point of water in Fahrenheit is 32. So that's why we have to add it to 32 because the freezing point of Celsius is 0. So we add the 32. That's our freezing point. Now the 9/5 is the ratio. Okay, we'll get into ratios in a little while. All right, so now find F when C is 25. So we have F equals 9 over 5 times 25 plus 32. When you don't see a denominator, remember it's automatically in the numerator. We can see that if we do this. All right, but notice I have a 5 here and a 25. Well, 25 is 5 times 5. So I can get rid of one of the 5s. I can cross it out. 9 times 5, we have to do our GEMDOS, so it's 9 times 5 is 45. That's the first thing we do. Plus our 32. So now I have 77 degrees Fahrenheit. So 25C is 77 Fahrenheit. A lovely day. Thank you very much. All right.